Assalamu alaikum and welcome to Megatopia. In today's video, we are going to discuss about 20 electrical circuit components that are used in our daily life. So grab a cup of tea and let's get started. So the first component that we are going to discuss in today's video is a resistor. A resistor is an electronic component that restricts the flow of electric current in a circuit. So what are the function of a resistor? The main function of a resistor is that it restricts the flow of current passing through a circuit so that it can be protected from overloading and burning. There are two main types of resistor. One of them is a fixed resistor that have a fixed constant resistance and are used in our daily life. Another type is a variable resistor that allow adjustment of resistor. The main applications of the resistor is circuit protection, signal conditioning mean it helps in shaping and adjusting signal in audio and communication devices. Another important application is biasing that sets the operating point of transistor and other devices. In conclusion, a circuit is a device that manage current flow and voltage level. Understanding their types, function and application is key to designing and troubleshooting electronic systems. So the next we are going to discuss about capacitor. That what is a capacitor? A capacitor is an electrical component that stores and releases electrical energy. It consists of two conductive plates separated by an insulating material known as dielectric. So how a capacitor works? First step is charging. When a voltage applied across the plate, an electric field develops, causing positive charge to accumulate on one plate and negative charge on another. It also stores energy. The energy is stored in the electric field between the plates. Discharge. When connected to a circuit, the stored energy can be released to power the circuit. Types of capacitor. There are different types of capacitor. A ceramic capacitor that is widely used for their small sizes and reliability, ideal for high frequency application. Another type is electrolytic capacitor, known for high capacitance value commonly used in power supply circuit. Another type is film capacitor. It offers good stability and low ESR, suitable for audio application. So, what is the main application of the capacitor? It is used to filter power supply, means it smooths out voltage fluctuation in power supply. It also used for timing circuits, working with resistor to create a delay circuit. Also used for energy storage like flash photography and electric vehicles. What is an inductor? An inductor is a passive electrical component that stores energy in a magnetic field. When electrical current flows through it, it is typically composed of coil and a wire. So how does a inductor work? When a current passes through the inductor, a magnetic field is created around the coil. This magnetic field stores energy. The amount of energy stored is proportional to the square of the current. When the current changes, the magnetic field also changes, inducing a voltage that opposes the change in current. This phenomenon is known as Lenz's law. There are different types of inductor. First of all, is a air core inductor that is made without a magnetic core suitable for high frequency application. Another type is iron core inductor, use a magnetic core to increase inductance commonly found in power application. So why we use an inductor? The main application or use of inductor is that we use it in power supplies that used for energy storage and filtering in switching power supplies. It also used in signal processing, employed in filters and oscillators to manipulate signal frequencies. Also used in transformer, essential component in transformers, allowing voltage transformation in circuit. Now, what is a diode? A diode is a semiconductor device that allows current to flow in one direction while blocking it in the opposite direction. It is a fundamental component in electronic circuit. So, what is a p-n junction? A diode is made up of two layers of semiconductor material, P-type and N-type. The interface between these layers forms a p-n junction. Forward biasing. When a positive voltage is applied to the P side relative to the N side, the diode conducts electricity. And reverse biasing is that when the voltage is reversed, the diode blocks the current flow, allowing minimal leakage. There are different types of diode. A standard diode is used for general rectification, converting AC to DC. Another is Zener diode that is designed to allow current to flow in the reverse direction at a specified voltage used for voltage regulation. Another type is Schottky diode, known for the lowered forward voltage drop and fast switching speed, ideal for high frequency application. So, what are the applications of a diode? Simply, the first and the most important application of the diode is rectification to convert AC into DC in power supply. It is also used in clamping circuits, protecting circuit from voltage spikes. Signal demodulation is one of the most important application of the diode, extracting information from modulated signal in communication system. Transistor is another semiconductor device that is used for amplify or switch electronic signal. It is a fundamental building block in modern electronics. So, how does a transistor works? Transistor typically has three layers of semiconductor material forming either NPN or PNP junction. An junction composed of two N-type layer and one P-type, and a PNP composed of two P-type and one N-type layer. Operation. Amplification is the one of the most important operation of the transistor. A small input current at the base terminal control a large current flowing between the collector and emitter terminal. Switching is another operation of it. By applying a voltage to the base, the transistor can turn and on, allowing current flow or off stop current flow in a circuit. So, what are the applications of the transistor? Amplifiers are the most important application of the transistors used in audio equipment to enhance sound signal. Switching circuit is another application. It acts as electronic switches in digital circuit. It is also used to generate waveform of radio frequency and the next component is transformer. It is an electrical device that is used to transfer electrical energy between two or more electric circuits through electromagnetic induction. It changes the voltage level in AC circuits. So, how does a transformer work? The basic structure of a transformer is that a transformer consists of two coils. One is primary and second is secondary, wounded around a magnetic coil. The primary coil is connected to the input voltage source and the secondary coil is connected to the output voltage or load. Electromagnetic induction. When alternating current flows through the primary coil, it can creates a magnetic field around the coil. This magnetic field induces a voltage in the secondary coil. Voltage transformation. Step up transformer increases voltage from primary to secondary, more turns in the secondary coil. Step down transformer decreases voltage from primary to secondary, more turns in the primary coil. There are many types of transformers. One of them are power transformers that are used in electrical power distribution to set up or step down voltage. Isolation transformer provides electrical isolation between circuits while maintaining the same voltage. Auto transformer are used as single winding for both primary and secondary, allowing for a variable voltage output. The application of a transformer are power distribution, signal isolation, used in audio and communication system to reduce noise and interference. Voltage regulation maintains stable voltage level in various electronic devices. Next we have switch. A switch is an electrical device that can open or close a circuit, controlling the flow of electrical current. It is a fundamental component in electrical and electronic system. So how does a switch work? Basically, a switch can either connect or disconnect the electrical circuit. Types of operation. Manual switch operated by a user, automatic switch operated based on specific condition. The types of switch. There are different types of switch. Toggle switches are lever or handle that moves between two positions. Push button switch activates the circuit when pressed and may return to its state. Rocker switch, a flat switch that rock back and forth to change its position. Slide switches operated by sliding a knob or lever to open or close the circuit. So application of switch is that it helps us control different components. It manage the power and helps in automation system like incorporated in smart house devices and industrial automation. So next in our list is a fuse. A fuse is a safety device that protects electrical circuit from overload or short circuits by breaking the circuit where excessive current flows. A fuse consists of a metal wire or a strip that melts when the current exceeds a specified level. A current flow through the fuse without any interruption means that it is normal operating. But if the current exceeds the fuse rating, the wire melt, interrupting the circuit and preventing damage to other devices. That is an overload condition. So the different types of fuse are the glass fuse, commonly used in household appliances, transparent for easy inspection. Another type is a ceramic fuse, which offer a high resistance to heat and are used in high power application. A blade fuses are also widely used in automotive application, easy to replace and check. The application of fuse are that it is used in household appliances, automotive industry, and in industrial equipment so that they are not damaged by excessive current. Relay. A relay is an electromechanical switch that uses an electromagnetic coil to open or close a circuit. It allows a low power signal to control a high power circuit. So, how a relay works? Basically, a relay consists of an electromagnetic coil, an armature moving lever, and one or more set of contacts. Energizing the coil when a small current flows through the coil, it creates a magnetic field that pulls the armature This movement either connect or disconnect the contact, allowing or stopping current flow in the control circuit. There are different types of relay. Electromechanical relays is used in mechanical movement to switch circuit. Reliable but can be slower. Solid state relay are used semiconductor component for switching faster and more durable but may have high cost. Reed relays contain reed switches sealed in a glass tube, suitable for low power application. So, what are the application of a relay? The application of a relay are they are used in automotive, control lighting, motor, and other electrical component in vehicle. Also used in home automation, used in smart home system to control light and application. It is also used in industries to control the automated machine so that it can be controlled easily. So next we have battery. A battery is a device that stores chemical energy and converts it into electrical energy through electrochemical reaction. It provides power to various electronic devices. So how a battery works? A battery consists of an anode, a negative electrode where oxidation occurs, releasing electrons. Another cathode, the positive electrode where reduction occurs, accepting electrons. Electrolyte is the medium that allows ions to move between the anode and cathode, facilitating the chemical reaction. Energy conversion. When the battery is connected to a circuit, a chemical reaction occurs producing electrons that flow from the anode to the cathode, generating electrical current. Different types of battery. Primary batteries are the batteries that are non-rechargeable batteries designed for single use. Secondary batteries are rechargeable batteries that can be used for multiple times. Lead acid batteries are common in automotive application, known for high capacity and low cost, but heavier and less efficient. The application of a battery is consumer electronics powering devices like smartphones, laptops, and cameras. Electric vehicle providing energy for electric and hybrid vehicle. Renewable energy system is storing energy from solar panels and wind turbine for later uses. So next we have LED, also known as light emitting diode. It is a type of semiconductor that emit light when an electric current passes through it. LEDs are widely used for their efficiency and long lifespan. So basically how an LED works. An LED consists of a chip made from semiconductor materials, usually gallium, arsenium, or phosphide. When electricity flows through the LED, electrons recombine with holes in the semiconductor. This recombination releases energy in the form of light. The color of the light depends on the material used in the semiconductor. Standard LEDs, commonly used in indicator and display. This is a type of LED. The other types are high power LED used in application requiring bright lights such as street lights and automotive headlights. RGB lights are capable of producing a range of color by combining red, green, and blue light. Application it is used for lighting, displays, and in indicators. Now moving forward, we have a potentiometer. A potentiometer refers to a conceptual tool used in various fields, particularly in physics and engineering, to measure potential energy difference or electrical potential. The application of the potentiometer is that it is used in circuit to measure voltage, essential in analyzing electrical system and ensuring system. The potentiometer, often known as wattmeter, provides critical data for engineers and technicians in designing and troubleshooting circuit. In conclusion, understanding potentiometer is crucial for anyone working with electrical system. This play a significant role in ensuring efficiency and safety in technology and engineering. A potentiometer is a three-terminal resistor with a sliding or rotating contact that form an adjusting voltage divider, also known as a voltage divider. So next we have voltage source. A voltage source is a device that provides a constant voltage to an electrical circuit. It can supply electrical energy to power device. Types of voltage sources. Ideal voltage source provides a constant voltage regardless to the current drawn. It is a theoretical concept not found in reality. Real voltage source provide a voltage but may vary under different conditions. Examples are batteries and power supplies. So, the common example of a voltage source are batteries, AC power sources, and DC power supplies. Application of voltage sources are electronic powering circuit in devices like smartphones and computer, supplying power to machinery and equipment, solar panel and wind turbines acts as a voltage source. Similarly, we have current source. A current source is a device that delivers a constant current to a circuit regardless of the voltage loss. It ensures that a specific amount of electrical charge flows. Types of current sources. Ideal current source provide a constant current without any change due to voltage variation. It is a theoretical concept does not exist in practical life. Real voltage source supplies a constant current can vary with load changes. Constant current diode current regulating circuits are the example of real current sources. Characteristic of current source. Current level. The specific current it supplies is 1 milliamp or 10 milliamp. The common examples of current source are LED drivers, transistor, and current regulator. The application of current sources are that they are used in application where constant current is vital, such as sensors. Analog circuit essential for biasing and amplifying circuit. It is also used for testing equipment, used in laboratories for testing components. IC, also known as integrated circuits, are tiny electronic circuits that combine multiple components onto a single chip of semiconductor material. They perform various functions including amplification, signal processing, and computing. In 1958, first IC developed by Jack Kilby at Texas Instruments. So there are different types of ICs. Like analog ICs handle continuous signal like amplifiers. Digital IC process discrete signals. For example, microprocessor. Mixed signal ICs combine both analog and digital. The key component of ICs are transistors, resistor, capacitors, and wires that link the component to the chips. So, how are IC work? Functionally, IC use transistors to switch signal on and off, creating binary data zeros and ones. Integration, multiple functions are integrated on a single chip, reducing size and cost while increasing reliability. Advantages of IC are that it is cost effective, small in size, reliable, and provide us a good performance. The application of ICs are that they are used in electronics like smartphones, computer, and television, uses automotives, telecommunication, and different medical devices. So next we have semiconductor. Semiconductors are materials that have electrical conductivity between conductors and insulators. Common materials are silicon, germanium, and gallium. Properties of a semiconductor. A semiconductor can conduct electricity under certain conditions. A band gap is a small energy gap between the valence band and conduction band, which allows them to be modified by temperature or impurities. Doping is the process of adding impurities to enhance conductivity. There are two major types of semiconductor: intrinsic semiconductor, pure form without impurities; extrinsic semiconductor, doped with impurity to increase conductivity. N type is doped with elements that have extra electron, and P type is doped with elements that carry holes. So, how a semiconductor works? Electron can move from the valence band to the conduction band, allowing current to flow. Semiconductors are used to make transistors, which act as switches or amplifiers in the circuit. The application of semiconductor: electronics, solar cells, LEDs, sensors. These are the important application of the semiconductor. The advantage of semiconductor is that it is a versatile mean can be used in a wide range of applications. Efficiency, energy efficient and capable of high speed operation. Integration can be integrated into complex circuit, reducing the size and cost. Um, Speakers are devices that convert electrical signal into sound. They allow us to listen to music, speeches, and other audios. There are different types of speakers, such as dynamic speakers. They are most widely used speakers. Another type are electrostatic speakers. Use a thin diaphragm between two conductive plates, known for their excellent sound quality and details. Horn speaker utilizes a horn structure to amplify sound, great for large space due to their high efficiency. Subwoofer designed to reproduce low frequency sounds, commonly used in home theater and music events. So, how a speaker works? A speaker receives a signal from the device like phone and component. The electrical signals are amplified to drive the speaker. The driver vibrate, creating sound waves that travel through the air. So, the application of a speaker are in our daily life. We use this in our home, public speaking, theater, sound system, and musical instrument. In conclusion, speakers are vital for delivering sound in various contexts, from personal enjoyment to professional setting. Understanding their type and function help us choosing the right speaker for the specific needs. So, a microprocessor is a small computing device that acts as the brain. It processes instructions and performs calculation to execute tasks. Microprocessors are essential in computers, smartphones, appliances, and many electronic devices. The first microprocessor was introduced in 1971. The Intel 4004 was the first commercially available microprocessor. So, how a microprocessor works? A microprocessor receives data and instruction from input devices like keyboard and cells. Execute operation based on the instruction using its algorithm and logic unit. Send proceed data to output devices like monitor and printers. The types of microprocessor are the general purpose microprocessor used in personal computer and laptop. Example including Intel and AMD processor. Embedded processor found in devices like microwaves, cars, and other devices. Digital signal processor specialized for processing audio, video, and other signal types. The application of microprocessor are computing devices, consumer electronics, automotive systems, industrial automation. In conclusion, microprocessors are crucial components for modern technology, enabling devices to function intelligently. Understanding their structure and application help us appreciate their role in our daily life. Neon lamp is a type of gas discharging lamp that produces light when an electric current passes through a gas, typically neon. A neon gas works when a neon lamp are filled with low pressure neon gas. When voltage is applied, the gas ionizes, allowing current to flow and creating light. The neon gas then emits a bright orange red glow when energized. There are different types of neon lamps. Standard neon lamp emits a characteristic red orange light primarily using neon gas in decorative lighting and indicator. The advantages of neon lamp is that they have long lifespan, low energy consumption, bright and eye-catchy color. The disadvantages are they are fragile, require high voltage, and limited specific specific application. Conclusion: neon lamp a versatile lighting solution that combine functionality and aesthetic. Their unique glow has made them a staple in advertising and decorative light. So, what is an Nex tube? An Nex tube is an electronic device used to display numerical digit. Consists of a gas-filled tube containing cathode shaped like numbers. It was developed in 1950s. At that time, it was used for digital display. So, how a Nex tube works? The tube contains a low pressure gas like neon and multiple cathodes shaped like the digits. When a voltage is applied to a specific cathode, it ionizes the gas around it, causing the number to glow. The illuminated digit is visible through the glass, creating a bright and clear display. The key components of the Nex tube was a glass envelope cathode, anode, and the application of the Nex tube are they are used in clocks, measuring instrument like used in voltmeter and other devices requiring digital display, decorative display favored in art installation and novelty item for their vintage look. The advantage of this tube was it gave a retro appearance that appealed to enthusiasts, bright and easy to read display, and long lifespan when used properly. The disadvantages was it was more fragile than modern LED display, limited to numerical display and high power consumption. But in conclusion, Nexi Tube are a fascinating piece of technology that combine vintage charm with functional design. They offer a unique way to display number and have found new life in modern application. So that is all for today. I hope you enjoyed the video.